Welcome to aminacademy.com. In astronomy, let us discuss about Earth's atmosphere and Hubble Space Telescope. Earth's atmosphere blocks most radiation at wavelengths shorter than visible light. So we can only make direct ultraviolet X-ray and gamma ray observations from space. Through indirect gamma ray observations can be made from Earth. Getting above the distorting effects of the atmosphere is also an advantage at visible and infrared wavelengths. The stars don't twinkle in space, so the amount of detail you can observe is limited only by the size of your instruments. On the other hand, it is expensive to place telescopes into space, and repairs can present a major challenge. This is why astronomers continue to build telescopes for use on the ground as well as for launching into space. Now, let us talk further about Hubble Space Telescope. In April 1990, a great leap forward in astronomy was made with the launch of the Hubble Space Telescope (HST) with an aperture of 2.4 meters. This is the largest telescope put into space so far. HST is operated jointly by NASA's Goddard Space Flight Center and the Space Telescope Science Institute in Baltimore. It was the first orbiting observatory designed to be served by shuttle astronauts, and other the years since it was launched. They made several visits to improve or replace its initial instruments and to repair some of the system that operates the spacecraft. Further, the feature of large telescopes. If you ever gone to hike, you have probably been eager to see what lies just around the next bend in the path. Researchers are no different, and astronomers and engineers are working on the technologies that will allow us to explore even more distant part of the universe and to see them more clearly. The premier space facility planned for the next decade is the James Webb Space Telescope, which it's in the future telescope, which is named after one of the early administrators of NASA instead of a scientist. This telescope will have a mirror 6 meters in diameter made up like the Keck telescopes in 36 small hexagons. These will have to unfold into place once the telescope reaches its stable orbit point, some 1.5 kilometers from Earth. Now we'll discuss further detail about Earth's atmosphere, Hubble Space Telescope. Observing celestial object and phenomenon beyond Earth's atmosphere, including ultraviolet, X-ray, and gamma ray observation, requires telescope and instruments placed in space, as the Earth's atmosphere blocks most of these wavelengths. Why space telescopes used? Earth's atmosphere absorbs or scatters most of the electromagnetic spectrum, making it difficult to observe certain wavelengths like ultraviolet, X-ray, and gamma ray radiations. Space telescopes like a Hubble Space Telescope are placed above the atmosphere to overcome these limitations, proving clearer and sharper images. Types of observations. First, ultraviolet, X-ray, and gamma ray. These high-energy electromagnetic waves are only observable from space. Infrared. While some infrared observations can be made from ground-based telescopes on dry mountain peak or from aircraft, space-based telescopes offer better resolutions and access to more wavelengths. Visible light. While visible light can be observed from the ground space telescopes, still offer advantages in terms of resolutions and seeing, as they are not affected by atmospheric turbulence. Example of space telescopes: Hubble Space Telescope (HST), the largest aperture telescopes in the space, providing a detailed image of astronomical objects. Spitzer Space Telescope, a significant infrared telescope. Chandra X-ray Observatory, a premier X-ray observatory. Fermi Gamma Ray Space Telescope, a premier gamma ray observatory. Now, the Hubble Space Telescopes, how it works, see this. The Hubble Space Telescope, a Cassegrain reflector telescope, collects and focuses light from the celestial objects using two mirrors and then direct into the instruments for analysis, allowing scientists to study the universe in visible, ultraviolet and infrared light. That means here focusing as well as observations are available in this telescope together. Cassegrain design. Hubble uses a Cassegrain reflector telescope's design, meaning light enters through an opening, hits a primary mirror, concave, bowl-shaped, and is reflected towards a secondary mirror, convex, dome-shaped. Light path. The secondary mirror reflects the light back towards the front of the telescope, where it passes through the hole in the primary mirror and is directed to science and guidance instrument. Mirror. The primary mirror of 7.9 feet, nearly 2.4 meters in diameter, while the secondary mirror 12 inches, that is 30.5 centimeters wide. Instruments. Hubble has various instruments including camera and spectrograph that can direct visible, ultraviolet and infrared light. Orbit. Hubble orbits Earth at an altitude of approximately 320 miles, this is nearly about 515 kilometers, allowing it to capture high resolution image which substantially lower background light than ground-based telescopes. Communications. Hubble uses the satellites to communicate with Earth, transmitting recording data in 1 megabits per second. That much fast. Power. Hubble is powered by solar energy collected by two wing-like solar arrays. Pointing. Hubble uses reaction wheels and small gyroscopes and magnetic torque rods to point the telescope. Orbit control. Hubble has no propulsion, so the orbit is entirely controlled by the Earth's gravity. Now, these are some important points in Hubble's telescopes. Now we'll discuss about the future of large telescopes. The future of large telescopes involve both ground-based and space-based observations, both together combined, with ongoing projects like the Giant Magellan Telescope (GMT) and the extremely large telescopes (ELT), as well as the future mission like the Habitable Worlds Observatory, aiming to push the boundaries of astronomical observations. So far we discussed about the Hubble telescopes as well observation outside the Earth's atmosphere. We have done. Please subscribe our YouTube channel.